Hello and welcome, amazing one. And in this tutorial, I'm going to teach you how to solve this beautiful equation. It's going to be amazing. And don't forget to tell us how it helps you in the comments. We always want to serve you best. Now let's do this together. So this is what we are given. You'll be like, where do you start from? I'm going to simplify it, okay? So we're going to begin this with solution. Now what do we do? Let's repeat what we have. We have 3 to the power of x plus 1 plus 3x is equal to 33. Now, we can choose to move this to the right side. Remember, it's addition, so you are going to subtract, okay? So we are going to have 3 to the power of x plus 1 is equal to 33. This will be minus 3x. Interesting. Now, what do you think we should do next? We just quickly need to remember that for every a to the power of m plus n, it is a to the power of m multiplied by a to the power of n. Now, can we apply this in this left side? Yes. And to do that, we are going to have 3 to the power of x, okay, is multiplied by 3 to the power of 1. I hope you're with me there. Is equal to. Now, for the right side, you observe that this something is common here. 33, as you know, is the same as 3 multiplied by 11. So 3 is common here, 3 is also common here. So we can quickly factor 3 out. Open up a bracket, use 3 to divide this, it gives you 11, okay? Use 3 to divide this, it gives you negative x. Interesting. Now, what do you do next? Keep engaging and see what to do next. 3 to the power of x multiplied by 3 to the power of 1 is the same as 3, okay? So we have multiplied by 3 is equal to 3 into 11 minus x. Now, what did you observe? You observe that 3 is common here and is also common here. So we can divide both sides since they are both multiplying, just to remove 3. So we divide this by 3 and also divide this by 3. If you do that, this cancels, this cancels. So you are left with 3 to the power of x is equal to 11 minus x. Interesting. Now, what do you do next? We are going to divide both sides by this, okay? So we're going to have 3 to the power of x, divide it by 3 to the power of x is equal to 11 minus x divided by 3 to the power of x. So what do you do next? Just remember, for each time you divide the number by itself, it gives you 1. So we have 1 is equal to. Now for this, we can rewrite this as 11 minus x is multiplied by 1 over 3 to the power of x. You've not changed anything. This can still be the same as over 1. When you multiply the two numerators, it gives you back this. When you multiply this and this, it gives you back 3 to the power of x. So you can change this to be in this form. So I am still free to remove this, okay? So this is the same as this. Now, what do you do next? I am going to show you. And don't forget to like this video, share it so that others will learn with you. Let's continue. Now, from here, this can also be rewritten. We can write this to be 11 minus x multiplied by 1 over 3 to the power of x is equal to 1. This and this are the same. Now we keep simplifying this. Just remember that for every 1 over a to the power of n, it is a to the power of negative n. Okay, so this is going to guide us to simplify this. Now this is giving us 11 minus x. Then this will now be 3 to the power of negative x is equal to 1. Now, when you have something like this, what do you do? Just quickly remember that for every a multiplied by e to the power of a, whenever you have a function of this form, you can quickly introduce your Lambert W function, and when you do that, it will be equal to a. Now, we are going to apply this Lambert W function in solving this. But when you look at this function, you observe carefully that for you to apply this, you have to make sure that what you have here is e. But when you look at this, you see what you have is 3. And also, the power should also be the same with the coefficient. Now you see the power we have here is negative x, and what we have here is 11 minus x. So at this point, we are going to do a little touching so that we put this in this form for us to apply the Lambert W function. So what we do first is, because what we have here is 11, we are going to multiply. So we have multiply both sides by 3 to the power of 11. So to now have, this will give us 11 minus x multiplied by 3 to the power of negative x will be multiplied by 3 to the power of 11, okay, is equal to 1 multiplied by 3 to the power of 11. Interesting. Now what do you do? Also remember, for every a to the power of m, just like we said earlier, plus n, it is equal to a to the power of m multiplied by a to the power of n. So you see that this is of this form. We are going to put this into this form. Okay, so we are going to add the powers. So in that case, we are going to have it as 11 minus x multiplied by 3. So you can add the powers because the bases are the same. So this what we have is equal to 1 times this gives us 3 to the power of 11. Interesting. Now what do you do? This is also the same as 11 minus x, 3 to the power of, this can also be written as 11 minus x is equal to 3 to the power of 11. Now what did you observe? You observe now that this power is the same as the coefficient, just like what we have here. But what you have here is 3, and what you should have is a. So what do you do? Just quickly remember that each time you have e raised to power of ln of a, it is always equal to this a. Okay, so what we are going to do is we are going to now put this 3 in this form. We have not changed anything, and to do that, see what we have. 11 minus x, okay, now this 3 we are going to put it in this form. So to now have e to the power of ln of 3, okay, this will still give you back 3, obeying this. So you've not changed anything. Then raise this 3 to your 11 minus x. I hope you're with me there. Now this is equal to 3 to the power of 11. Interesting. Now what do you do? Remember, for every ln of a to the power of x, this is your usual logarithm rule. It is equal to the power multiplied. So you have x ln of a. So we're going to apply this rule on this, just like we have it here. So we're going to have 11 minus x into e multiplied, you have this power multiplies the ln. So we're going to have 11 minus x ln of 3 is equal to, this will give us 3 to the power of 11. Now what did you observe? You observe now that the power is no longer the same with the coefficient having made this to be a. So what should you do so that the power and the coefficient will be the same? Just quickly multiply both sides by this ln of 3. Multiply both sides by ln of 3. Okay, so if you do that, we have 11 minus x multiplied by ln of 3. Then we now have e to the power of 11 minus x ln of 3 is equal to, multiply this also. So you have ln of 3 multiplied by 3 to the power of 11. Now what did you observe? You now observed that this power and this coefficient are the same, and this is now e. So you are free to introduce your Lambert W function. But wait, we can also do a little adjustment on the right side so that we apply it on both sides of the equation. Now to do that, we just also know that 3 to the power of 11 can be rewritten as 3 to the power of 2 multiplied by 3 to the power of 9. Because when you add these powers, it gives you back 11. Now what do we do? This is going to give us, so we're going to have 11 minus x then ln of 3 e to the power of 11 minus x ln of 3 is equal to ln of 3 multiplied by, this is 3 to the power of 2 multiplied by 3 to the power of 9. Interesting. So we can also rewrite this. So this gives us 11 minus x, then we have ln of 3. So we have e to the power of 11 minus x ln of 3 is equal to, now this 3 to the power of 2 is 3 times 3, which will give us 9. So we can have this as 9 ln of 3, okay, is multiplied by 3 to the power of 9. Now what do? You observe that this 3 to the power of 9, we can do an adjustment still on it, and to do that, see what we have. 11 minus x ln of 3 e to the power of 11 minus x ln of 3 is equal to 9 ln of 3 multiplied by, now this value, we know that e to the power of ln of a is equal to a. So we can change this value to put it in this form, to have e to the power of ln of our a will be 3 to the power of 9. This will give you back 3 to the power of 9. So what do? You keep simplifying to have 11 minus x, then ln of 3 e to the power of 11 minus x ln of 3 is equal to, this gives us 9 ln of 3, then we have this power multiplies the ln, so we have e to the power of 9 ln of 3. Interesting. So what did you observe? You observed that this power, like we said, is the same as the coefficient, and what you have here is e. And also this power and this coefficient are the same, and what you have here is e. So you are free to introduce the Lambert W function. So we take the Lambert W function for every a to the power of e, a is equal to a. Okay, so applying it here, we are going to have the Lambert W function of what you have here as 11 minus x ln of 3 e to the power of 11 minus x ln of 3, okay, is equal to the Lambert W function of 9 ln of 3 e to the power of 9 ln of 3. Interesting. So this is going to give us, obeying what we have stated here, we are going to have it as, this will give us 11 minus x ln of 3, okay, is equal to, for this and this are the same, just take one, so we have 9 ln of 3. So what do? To remove this ln of 3, since it's common, divide both sides by ln of 3, okay, this will cancel, this will cancel, so we are left with 11 minus x is equal to 9. Now what do you do to get x? You can now bring this to the right, to the left side is addition, so you subtract, and then take this to the right side, you add. You're going to have 11 minus 9 is equal to, this will become x. Simplifying more, we're going to have 11 minus 9 will give us 2 is equal to x. So this implies the value of x is 2. And this is our answer. So to check if this answer is correct, we plug this value at the left side to see if it gives us 33. So to do the check, we are going to have, put x as 2, we have 3 to the power of 2 plus 1, then plus 3 multiplied by 2. Will this be equal to 33? This gives us 3, add this, it will give us 3 plus 3 times this gives us 6. And 3 to the power of 3 is 3 multiplied 3 times, okay, then plus 6. This will give us 27. 27 add 6 gives us 33, and that is what we have at the right side. So it means that the value of x as 2 is correct, and I hope this really helps you a lot. Don't forget to let us know how much. Share this so that the algorithm catches it and send to more people that need this skill. Don't forget to tell us how it helps you in the comments. Give this a thumbs up. Thank you for always engaging. See you in our next class. Bye bye.